Welcome, pre-calculus students, to week 6 of distance learning. This week we're going to be talking about limits. You can think about where you may have heard the term limit before. A lot of people think to the movie Mean Girls, where she says the limit does not exist. Okay, they were talking about limits. That's what we're going to be looking into this week. What you're going to see up here on the board are important formulas and properties dealing with limits. So when you think about a limit is where is the function going, or where is it coming to at a particular x value. Now there are a few ways that we can do this and evaluate where it's going to be. Okay, sometimes people will go to their graphs in their graphing calculator and look at the graph and see where it's coming to, and then others may look at the table. You can go to your table and see, well, if you're looking for where x is going to 2, you could look at 0, 1, and maybe 4 and 3, and kind of see where it is coming to at 2. And then the third way is using algebra. That's the way we're going to be looking at this week, is using algebra to determine where is the function going to at a particular x value. When writing limits, you will always see LIM, that means the limit, and then below, and then you'll see below that the x, or the variable that you're looking at, going to a particular number. So that means when x approaches a number, whatever number that may be. It could be 2, it could be infinity, it could be negative infinity, whatever number is written there. And then next to that is the function that you're going to be looking at. So, as an example, limit of x goes to 2 for the function x squared. So the function x squared, and you're looking for what is approaching as it gets to 2. And in this case, it goes to 4. So function limits. The first one, the limit is x goes to c, so any number, of a constant function. So the limit is x goes to any number of 5 is always going to be that number of that function, 5, because it is always going to be at that number. The second one, the limit as x goes to c of x, so thinking of a 1x line, all you're going to do there is plug that c in, and that's going to equal c. Next, we have the limit properties. The limit properties allow you to take things that have compositions of functions or combinations of functions. So if you see the limit of x goes to c, or any number, f of x plus g of x. So two functions being added together. Then you could separate them apart and evaluate the limit for each piece and add them together. Same thing works when you're subtracting. The limit is x goes to c, and then f of x minus g of x, you could separate them into their own limits and then subtract your answers. And then the third one is going to be if you have a constant being multiplied by a function. So 3x. You could take that 3 out and put it out in front, and then you could look at the limit of the x function. The next one is when you do multiplications. Okay, multiplication, same way. You can separate them and then evaluate the limit for each piece and multiply your answers. And then division, same thing. You can divide, or you can separate them out, do the limit of the top divided by the limit of the bottom. Only parameter here is that the bottom cannot have a limit that equals 0. Otherwise, it would be undefined. And then the next one is if you have a power. You can take the limit of the piece and then take it to the power. With the last one, we have a root. Same thing as before with the power, same thing here with the root. You can take the root out of the whole thing and put it over the limit of your function. And the only parameter here is that the limit has to be greater than 0 if n is even, because it has to be square root, and you can't take the square root of the negative number. Now, as you have a chance to write that down in a few moments, we're going to be looking at some examples. And while we look at some of these examples, just be remembering that limits is just where's the function at that particular spot. Where is it going to? Where is it coming in at for that spot? Now we're ready to look at some examples for limits. I have written 9 examples up here on the board, and we're going to work through the examples one at a time. Starting with example A. Example A is the limit as x goes to 2 of negative x to the third plus 4. So for this example, we're going to be plugging in 2 into our x value. So when you plug in 2, you have negative and then 2 to the third power plus 4. So negative 8 plus 4. Negative 8 plus 4 is negative 4. That's the limit as x goes to 2 of that function. Part B, we're dividing this time. So we're going to go ahead and use the quotient property of limits, which we saw on the first board of notes. So we can write it this way, or you could simply just plug 2 in for your x's and evaluate. Then you would get negative 1 over negative 9, or 1/9. Next one, limit as x goes to negative 8 of the square root of x plus 6. Now what you're going to notice is if we do the same thing we did in A and B, where you sub it in, negative 8 plus 6 is still a negative number, so we can't take the square root of that. So this one is not possible. That finishes up the C example, so now I'm going to erase those 3 to give us more room for the next examples. Part D. You have the limit as x goes to negative 2 of x to the third minus 3x squared minus 4x plus 12 on top, and then x plus 2 on the bottom. So if we subbed in that negative 2 to the top and the bottom, what you would get is 0 over 0. When you get 0 over 0, that should send up a red flag that this is what is called an intermediate form. What an intermediate form means is that you can factor out something on the top and the bottom. So kind of like how we were doing earlier in the year with the rationals, we would take factors out. Or if you think about rational graphs, that factored out that particular whole. So that's what actually is happening here, is that we have a hole in the graph at that particular number, and we want to take it out so that we can see where the limit actually exists. Now we could do one of 2 things to factor out. What we could do is we could divide using long division or synthetic division in this case. So I chose to use synthetic division. That means that I would take the factor that we're trying to divide, x plus 2, and we solved it. You would get negative 2. Then I would use my coefficients that are in the numerator, 1, negative 3, negative 4, and 12, and synthetically divide. When you do, you're going to get 1x squared minus 5x plus 6 with no remainder. So essentially what you see on top is you have what you divided out, the x plus 2, and then you have what's left, the 1x squared minus 5x plus 6. So now we would do the limit of what's left. So the limit is x goes to negative 2 of x squared minus 5x plus 6. Negative 2 squared is 4, minus 5 times negative 2 or 10, so 14, plus 6 gives you 20. So the limit in this case is 20. When you're thinking back to the original function that was given, what ends up happening in this case is that the function's approaching 20 from both sides, and then at 20, it's a hole on the graph. So that's what we did. We divided out that hole so that we could get the actual limit of this function. And that's your answer for letter D. Letter E. The limit as x goes to 25 of x minus 25 on top, and then the square root of x minus 5 on the bottom. If you sub in 25 on both top and bottom, what you're going to get is 25 minus 25 is 0, and then the square root of 25, or 5, minus 5 is 0. So there again, red flag. We have an intermediate form, which that means that we need to do something here. And in this case, because we're dealing with a radical, we're not going to be doing division here. What we're going to be doing when we see this radical on the bottom, since there's a radical on the bottom, rationalize. So in this case, we multiply by the conjugate, or just changing our signs. And what ends up happening is that denominator, that radical piece, will cancel out with one of your two multiplications from the numerators. So x minus 25 will cancel out on top and bottom. And then you'll use the limit as x goes to 25 of just what's left, or the square root of x plus 5. So plugging it in, 25 square rooted is 5, plus 5 is 10. So 10 is your limit. So with the last four, you're going to be looking at going to positive or negative infinity for your limits. When doing so, you want to look at your degree and your coefficients of these functions that you're looking at. Letter F. Letter F is x going to infinity, and then the function here is negative x to the third. So that means 3 is the degree of this function. It's the highest exponent of the functions. That's the one we're going to zero in on. And because of the fact that that's a negative, so whatever number is getting plugged in here to the third power, you're still going to be tacking on that negative at the end, which means that as it goes to infinity, the answer is going to be negative infinity. Letter G, the limit as x goes to negative infinity of 4x to the 6th plus 3x to the 5th minus x. So 6 is the degree, so we're going to zero in on this 4x to the 6th. If you take a negative to the 6th power, it turns it back to positive. And because our coefficient out in front is positive, we know that this one is going to go to infinity. So when you look at this one, it kind of follows the same rules as Algebra 1 or Algebra 2, where you have an even function, so it means it's going in the same direction, and since it's positive, both sides are going to positive infinity. So as the limit goes to negative infinity, you're going to be at the positive infinity number. Letter H, the limit as x goes to negative infinity and the function is 5 over x minus 10. So for this one, what ends up happening here is this top stays the same, but the bottom, x minus 10, is getting bigger and bigger and bigger and bigger. So if you have 5 and the number below it becomes astronomical, it is getting closer and closer and closer and closer to 0. And then the last one, letter I, the limit as x goes to infinity of, and then the fraction is negative 3x squared plus 7 over 5x plus 1. So in this case, you want to watch your degrees. The degree on top is 2, and the degree on bottom is 1. So that means the top is going to be getting bigger exponentially. It's going to be getting bigger and bigger and bigger than the bottom. But what ends up happening is the coefficient in front of it is a negative 3. So even though it's getting bigger and bigger and bigger and bigger, it's getting bigger and bigger and bigger negative numbers. So that means that we are going to have a limit of negative infinity. So with looking at these infinite limits, make sure that you're looking at the degrees and the coefficients of these functions so you notice kind of what it's doing. Is the top bigger? Then that means it's going to be going to infinity or negative infinity. Is the bottom bigger? Then that means it's going to be going to 0. So that's how you would look at these last 4. That finishes up the examples for this lesson. So now what you're going to see is the assignment below. As always, please feel free to reply, post, chat, or email me questions. I'll be glad to answer them. For this week, I'm going to be praying over each and every one of you. I'm hoping that you guys have a great week, and I'm praying that I see you guys soon.